Hello guys, hope you have been having a great day. In the previous videos we have found out how to draw the oriented graph from a given power system network and how to draw a tree and cotree and etc. from an oriented graph. Now in this video let us learn about something called the node incidence matrix and the bus incidence matrix and how to derive them from an oriented graph. So for example, I'm considering an oriented graph which I'm drawing here with the nodes 1, 2, 3 and 0, where 0 is my reference node, and now I'm connecting them. 1 and 2 is connected, 2 and 3 is connected, 3 and 0, 1 and 0, and directions are important. You have to see the directions when you want to draw the node incidence or the bus incidence matrices. So once I'm done with connecting the nodes, I'll mark the directions. So once you have marked all the directions, you also are given the names for the elements. Say this is a branch, say 1, 2 is a branch. I have a name for that element or branch or a link. Every link and every branch is given a name or a number. So when I refer to node 1, that is the one in the black one, when I'm referring to the element 1, it is the branch that connects the nodes 1 and 0, and the element 6 connects the nodes 1 and 2, and in the same way element 5 connects 1 and 3, element 4 connects 0 and 3, this is 2 and this is 3, and this direction goes down like this. Now this is my oriented graph, which we are going to use as an example to construct the bus incidence matrix. So before we find out or construct the bus incidence matrix, we need to construct something called the node incidence matrix. So the bus incidence matrix or the node incidence matrix actually gives you the relation between, or actually tells you how the nodes and the different nodes in a graph are communicating with each other. I mean, how they are all connected with each other and what directions the flow is in between them. So that is given by the bus incidence matrix or node incidence matrix. Both they give the same thing. So now let us construct the node incidence matrix without any further ado. Now, the node incidence matrix, what we are talking about, is of the order E by n. E by n, where E is the number of elements in the oriented graph. In this oriented graph which I have drawn, how many elements are there? 6. How many nodes are there? Come on. We have 4 nodes, including the reference node. Consider 0 as a node as well. Now, this is the order of the node incidence matrix. Okay, remember, don't get confused between the bus incidence matrix and the node incidence matrix. So now, all you need to do is write down the different elements 1, 2, 3, 4, 5, 6. I have different elements on the left side, or I have those many rows and the nodes on as the columns. So I have 0, 1, 2 and 3. So now we are going to fill up the node incidence matrix. Simple thing. When I'm connecting, these are the elements. Okay? These are the elements and those are the nodes. Now, the element 1. the element 1. Is the element 1 touching or connecting or attached to the node 0? Yes, it is. The element 1 is attached to the node 0, yes. Now, is the direction of the element 1 towards node 0 or away from node 0? It is away from node 0. So, you write a 1. Now, yes, I think you're getting it. When the element, whatever element, there are 6 elements. So if an element touches any specific node, then you get a 1 or a -1. If the element does not touch a node, then you get a 0 in that place. Now, when the element touches a node, I told you you get a 1 or -1. Now, when do I get 1 and when do I get -1? I get 1 when the element is away from the node, or when the element is not incident to the node. Okay? Then you get a 1. If the element is incident to the node, or when the element is pointing to the node, then you get a -1. Say, for example, there is the element 6. I have the element 6 and I have the node 2. Node 2 and element 6. Yes, element 6 is touching node 2 and it is incident to node 2. So I write -1. Is the element 6 touching node 3 or attached to node 3? No, I write 0. Now element 6 is touching node 1, but it is pointing away from node 1, so I write a 1. Is element 6 touching node 0? No, 0. That's it. That is how you fill it all up. Element 1 is touching node 0, so you get a 1 and it's away from it. Element 1 is touching node 1 and it is incident to node 1, so I put a -1. It's not touching 2, it's not touching 3. So now I have filled it up for element 1 and element 6. If you have noticed yet, the sum of all the elements in any specific row is 0. That is the speciality of the node incidence matrix, or this principle is particularly useful when you are constructing your oriented graph from your bus incidence matrix. I'll tell you how. So now I guess you can fill the rest of the things up. So element 2 is here. It's touching 0, yes. It's away from 0, yes. Not touching 1, touching 2, and it's pointed to 2 and 0. So now fill it all up. In this way, you can construct the node incidence matrix. So now, if he gives you in the question that this is the node incidence matrix of a particular oriented graph, can you construct the oriented graph from the matrix? Yes, you can. Write down the nodes and, depending upon these values, connect these elements and form the oriented graph. It's as simple as that. So now you can find out the oriented graph if you're given the incidence or the node incidence matrix, and you can find out the node incidence matrix if he is giving you the oriented graph. Very good. So now, what is the bus incidence matrix? The bus incidence matrix is nothing more than the node incidence matrix, except that you don't have the reference node in this. Oh yes, you delete the reference nodes column. So column 0 is not there. The matrix you're seeing right now is the bus incidence matrix. It's not the node incidence matrix, it's a bus incidence matrix. So your node incidence matrix minus the reference nodes column is your bus incidence matrix. So now, in the question, he might not give you the node incidence matrix directly. He might give you this. He might give you the bus incidence matrix and ask you to find out the oriented graph. In which case, you will have to write down the node incidence matrix first. And what did I tell you? Use the principle. This is my question. I'm constructing another column for the node incidence matrix. I know that the sum of all the elements in any row is 0. So to get a 0, I write a 1 here, and a 1 here, and this is already 0, so I write a 0 here. And to get a 0, I write a 1 here, and this is already 0, so no issues, and no issues here. So now I form the node incidence matrix from the given bus incidence matrix. And once I have the node incidence matrix, bingo, I can draw the oriented graph. So I hope all of you have understood how to draw the oriented graph from the node incidence matrix and how to construct the node incidence matrix from a given oriented graph, and what a bus incidence matrix is and stuff like that. So if you have any queries, please ping a message or comment, and thank you for watching and have a lovely day.